Hello students, I hope you all are doing well at your home. You must be going through the NCERT textbook. So, in this chapter so far we have studied, or in the previous class we had discussed about the techniques to separate components of a mixture. Today we will discuss about some more things which are given in this chapter, that is about physical and chemical changes. As you all are aware that physical change is those changes which takes place in the physical properties. For example, a baby growing into an adult, the size is increasing, so that is a physical change. When butter melts in a pan, that is also a physical change. When ice gets converted into water, that is a physical change because solid is changing to liquid. When you boil water, water is getting converted into vapor, that is also a physical change. So, what do we observe in case of physical change? Only the state or some physical properties are changing. But in chemical change, what do we observe? In a chemical change, the properties of the substance itself changes. That means in case of a chemical change, we obtain a new chemical substance having altogether a different properties. This process in which one substance undergoes a chemical change, it is called as chemical reaction. So, as you can read, a process in which one substance reacts with another to undergo a change in a chemical composition and brings change in the chemical properties of matter, and we get a new substance, is known as a chemical change. And a chemical change is also called as chemical reaction. Example of your chemical reactions: rusting of iron, burning of LPG. All these are example of your chemical changes. So, let us perform certain activities to understand chemical changes in a better way. So, what I have taken a cleaned magnesium ribbon, and as you can see, I am going to put it into the flame, and let us observe what is the change taking place. So, when I am putting that magnesium ribbon into the flame, what you can observe, dear students, that the magnesium ribbon is burning out with a dazzling white flame and gets converted into ash. As you can see, I have collected that ash. So, this is nothing but a chemical change because magnesium metal has converted into magnesium ash, that is magnesium oxide. So, this is an example of your chemical change. Let us perform another activity. So, what I am going to do here, I have taken aqueous solution of lead nitrate and aqueous solution of potassium iodide, and I am going to mix them to observe the changes taking place. So, observe it carefully. So, what I am going to do, I have taken lead nitrate solution and here I have taken potassium iodide, and I am going to transfer both the solution into a beaker. So, when I transfer both the solution into a beaker, dear students, what do you observe? You observe a very beautiful yellow color. That yellow color is due to formation of lead iodide, that is PbI2, which is insoluble. So, here lead iodide is formed from the reaction between lead nitrate and potassium iodide. So, this is also an example of your chemical change. The activities were very much interesting, and I think you understood what is physical change and what is chemical change. Now, at the beginning of this chapter, we had discussed that substances are classified into two types. One is pure substances, another one is mixture. So far, we have already discussed about mixtures and their properties and varieties of mixtures. Now, we are going to discuss something about pure substance. As all of you know, that pure substances are classified into two types. One is your elements and another one is your compound. And we all know that there are 118 elements are there in this nature. And again, your elements are classified into three important types: metals, metalloids and non-metals. So, metals and non-metals differ in their chemical properties drastically, pole apart from each other. Metalloids are those which are having the properties that is of in between metal and non-metals. For example, if you take example of metals, sodium is a metal, iron is a metal, gold is a metal, aluminum is a metal, copper is a metal. If you take the example of non-metals, carbon, nitrogen, oxygen, phosphorus, sulfur, these all are example of non-metals. And what are metalloids? What are the example of metalloids? As I already told, that metalloids are those elements which are having the properties in between that of metals and non-metals. For example, boron, silicon, polonium, arsenic, these all are example of your metalloids. Now dear students, let's distinguish between metal and non-metals based on their physical properties. What are the difference between them? If you look at the table, appearance, metals are lustrous, that means they have a shiny surface, whereas non-metals are dull in nature, that means they do not have any shiny appearance. But my dear students, chemistry is full of exception. Here also you will find an exception in case of non-metal, that iodine is a non-metal which is having metallic luster. It has a shiny surface like of your metals. Coming to the second property, hardness. Metals are generally hard. That means you cannot cut metals into pieces with the help of simple cutting tools. For example, with knife you cannot cut iron. Non-metals are soft. Generally like wood, you can cut it with the help of a knife, with the help of a sharp edge knife. But again here also some exceptions are there. There are certain metals which are also very soft, that means you can cut them with the help of a knife. That is your lithium, sodium and potassium. Similarly, in case of your non-metals, there is another exception. As you know, diamond is the hardest known substance and diamond is a form of carbon. Carbon is a non-metal, and here I want to quote one point, that diamond is an allotrope of carbon. You must be wondering, what is allotrope of carbon? Allotrope of carbon means is a physical form of carbon. There are certain elements which can exist in more than one physical form. Like your carbon exists in the form of coal, it exists in the form of graphite, it exists in the form of diamond, it exists in the form of fullerenes. So this property by which they can exhibit or they can exist in more than one physical form, that is called as allotropy, and these individual physical forms are called as allotropes. So moving on to the third property, that is malleability. Malleability means when you hit or hammer metals, they can be converted into thin sheets. Whereas if you hammer a non-metal, they are generally brittle and they will break down to small pieces. So we say metals are malleable and non-metals are non-malleable. That means metals can be converted into thin sheets. For example, you must be knowing that the chocolate wrappers are nothing but your aluminum foil. We use aluminum foil wrapping foods. So aluminum is a metal which has been converted into thin sheets. Coming to the next property, that is ductility. Metals can be converted into thin wires. They can be drawn into thin wires. And non-metals cannot be converted into thin wires because they are brittle in nature. Example, if you take the electrical wirings that we see at our home, is nothing but made up of metals. Although they have a covering of plastic or PVC on them. Why they have a coating of PVC or plastic on them? Because metals are conductor of electricity also. And if you touch a naked wire, you can get electrical shock. So here another property comes is your electrical conductivity of metal, that we will discuss little later. That means the property by which a metal can be drawn into thin wires is called as ductility, and that property we use for making jewelry, gold jewelry or silver jewelry, because they can be converted into thin wires and given many shape. Moving on to the next property, heat conduction. As all of you know, the utensils that we use at our home are made up of metals like aluminum vessels. So because metals are good conductor of heat and non-metals are poor conductor of heat, and that is the reason metals are made to, or we use metals to make utensils or cooking vessels. Whereas you can observe that a tawa or a pan has a wooden handle. Wood is a non-metal made up of non-metals. That is because non-metal will not conduct heat and we can hold that pan easily without damaging the hand or skin. So metals are good conductor of heat, non-metals are poor conductor of heat. But here is also another exception exists, that is mercury and lead are the two metals which are poor conductor of heat, and silver and copper are very good conductor of heat. Dear students, we use these properties in our day-to-day life. Moving on to the next, conduction of electricity. Here metals are good conductor of electricity, and because of that all the electrical equipments, all the electrical wirings are made up of metal because they are good conductor of electricity. On the opposite hand, non-metals are poor conductor of electricity, and that is why they are called as insulators. But again, chemistry is full of exception. In case of non-metal, there is one exception which can conduct electricity, and that non-metal is nothing but your carbon. Carbon in the form of graphite can conduct electricity. So dear students, these are certain properties on which we can distinguish between metal and non-metals. And another property that I want to quote, which is not there in the table, is your sonority. I think all of us go to the temple. When we pray in front of God, there is a bell in every temple. When we strike that bell, what happens? It produces a ringing sound. So sonority is the property of a metal by which they can produce ringing sound. Or accidentally, if utensil falls from your hand and strikes a hard surface, then they also produce a ringing sound. So we say metals are sonorous, non-metal are non-sonorous. So dear students, based on all these physical properties, metals and non-metals can be distinguished from each other. Now moving on to the next part of this content, easier to distinguish between mixtures and compound, as compound is another pure substance because it is made up of one kind of particles. The table will show you what are the basic difference between a mixture and compound. Now before we discuss that table, let us understand how compounds are formed. Compounds are formed due to chemical change taking place in a chemical substance. For example, when hydrogen reacts with oxygen, it produces water. That is a chemical reaction, and the substance that we got is a water, and water is a compound. Previously, while discussing about chemical changes, we observed that magnesium catches fire and produces a very beautiful dazzling white flame, and it produces an ash. What is that ash? That ash is nothing but magnesium oxide, and that is a compound. So when two metals react with each other or two elements react with each other, they can produce a new substance that is called as a compound. And in case of a compound, the composition is always constant, unlike your mixtures. In mixture, we have all those components in a random proportion. But observe in case of water. Water is formed only when two hydrogen, one oxygen will combine. No other combination will give us water molecule. That is why we say compounds are having a fixed composition. Look at the table now. Elements or compounds just mix together to form a mixture and no new compound is formed in case of your mixture. But when elements react or there is a chemical change takes place, then we get a new compound. Coming to the second point, mixture has variable composition. They can be taken in any random proportion. Whereas the composition of each new substance that we get in chemical reaction or during chemical change is always fixed. The third, mixture shows the properties of the constituent substances. That means if you take the component of a mixture, they never lose their property. They will always retain their properties. For example, if you dissolve sodium chloride, that is common salt, in water, both water and sodium chloride have their own individual property. The property is not lost during the formation of a mixture, unlike in case of a compound. As I have given one example, hydrogen when combines with oxygen, it forms water molecule. And all of you know that hydrogen is a combustible gas, it catches fire. Oxygen supports combustion. But look at water. Water is not combustible, neither it supports combustion. That means altogether we got a different property. Hydrogen and oxygen lost their property while forming into a new compound. So components of a mixture retains their property. In case of compound, the component loses their property. Coming to the fourth point, the constituent can be separated fairly easily by physical method. The constituent of a compound cannot be separated by simple physical method. They can only be separated by chemical or electrochemical reaction. What does that mean? That means the component of a mixture can be separated very easily. For example, sodium chloride can be obtained from seawater by a simple method of evaporation. Then sand and iron is also a mixture. Iron pins can be separated from sand by using a magnet. But can you separate hydrogen and oxygen from water by simple method? The answer is no. In order to obtain hydrogen and oxygen from water, it has to undergo a chemical process that is called as electrolysis. That means you cannot separate the component of a compound by simple techniques or simple physical method. So dear students, we will perform an activity to understand the difference between mixture and compound. We will perform an activity which is given in your syllabus, which is given in your book. That is, we will prepare a mixture of iron and sulfur powder, that is iron fillings and sulfur powder, and we will also prepare a compound of iron and sulfur. And there we will see all these properties, whether the components of a mixture can be separated or not, whether the components of a compound can be separated or not. So without any delay, let's perform a beautiful activity to understand the difference between mixtures and compound. So dear students, as you saw the difference between mixtures and compound, let us perform an activity to understand it much better way. So what I am going to do, we are going to make a mixture of sulfur powder and iron fillings, and we are going to make a compound of sulfur powder and iron fillings. So what I have done here, I have taken in a china dish sulfur powder and your iron fillings. I have mixed them thoroughly. As you can see, some greyish color you can also see along with that sulfur powder, yellowish sulfur powder. That is due to the presence of your iron fillings. So as we saw that mixture, the components can be separated out. So here also you can see, if I take a bar magnet and if I roll it around that sulfur powder, what you are going to observe is that gradually that iron fillings are getting separated out from the mixture of sulfur and iron fillings, and they are getting clinched to the bar magnet, indicating that sulfur powder and iron fillings forms a heterogeneous mixture and they can be separated using a bar magnet. So this is a mixture where the components retains their properties. Now let us perform or to make a compound of iron and sulfur. So for that, what we need to do, we'll take in another china dish a mixture of iron filings and sulfur powder, and we will heat it so as to obtain a compound of iron and sulfur, which is known as your iron sulfide, that is FeS. And you will observe there that the iron no longer will be attracted towards the magnet, and sulfur will also lose its property, and a new compound will be formed, that is your iron sulfide, which will have altogether a different property. So here what we are going to do is, we are going to heat the sulfur powder and iron fillings together in a china dish, and gradually what you will observe that the sulfur will start melting and iron will also start melting, and both of them will start reacting to form a black thick mass, and which is nothing but your iron sulfide. So dear students, as you can see, the sulfur powder and iron fillings are reacting with each other. Sulfur powder has melted, and now a new compound, a black mass has been formed. That black mass is nothing but your iron sulfide. So now if I take a magnet and if I roll it around here, you will see no iron filings are getting attracted to the magnet. That is because when chemical reaction is taking place, the sulfur powder as well as the iron fillings have lost their properties. This shows us that heating sulfur powder and iron fillings together is a chemical change, and a compound is formed, and the component of a compound cannot be separated using a simple technique like your magnetic separation. So this is the basic difference between a mixture and a compound. The component of a mixture can be separated, but the components of a compound cannot be separated using a simple technique. So dear students, let us quickly summarize what we have studied so far. We discussed about physical change and chemical changes. We discussed about classification of pure substances into elements and compound, classification of elements into metal, non-metals and metalloids. We discussed about the difference between the properties of metal and non-metals, and we discussed about the difference between mixtures and compound, how compounds are formed and how is it different from the mixture, and we observe a very beautiful activity today. Now let us see how much we have understood by solving some question. The first question in front of you, which of the following are chemical changes? 4 options are there. You have to find out which are chemical changes. First option, mixing of iron fillings and sand. Second option, cooking of food. Third option, digestion of food. Fourth is a freezing of water. So the answer to it is your cooking of food and digestion of food are both chemical changes. The other two are your physical changes. Next question in front of you. Classify the following into elements, compound and mixture. There are 5 things are given. You have to classify each of them into elements, compound and mixture. I think you all can do it. You all can solve it. Let me tell you the answer. Sodium is an element. Soil is a mixture. Sugar solution is also a mixture. Silver is an element. Calcium carbonate is a compound. So that's all about the chapter Is Matter Around Us Pure? Let us look at, after studying this, after learning this chapter, what we have gathered, what knowledge we have gathered. The learning outcomes from here is, a mixture contains more than one substance mixed in any proportion. Mixture can be separated into pure substances using appropriate separation techniques. A solution is homogeneous mixture of 2 or more substances. The major component of a solution is called a solvent and the minor is called as the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution or solvent. Materials that are insoluble in a solvent and have a particle that are visible to naked eyes from a suspension. A suspension is a heterogeneous mixture. Colloids are a heterogeneous mixture in which the particle size is to be seen with naked eye but is big enough to scatter up light. Pure substances can be classified as elements or compounds. An element is a form of matter that cannot be broken down by chemical reaction into simpler substances. A compound is a substance composed of two or more different type of elements chemically combined in a fixed proportion. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituent elements or compound. So, my suggestion for you, you must go through the NCERT book and do solve all the in-text question and the exercise question provided over there. Along with that, to go for a understanding and application based question, you must solve the NCERT exemplar. Learning by doing is the best method to learn science. Explore your surrounding, observe your surrounding, and try to find out the reason behind all the scientific phenomena that we observe in our surrounding. Thank you.